Okay, here's question 18. It says, suppose a trial had been performed in experiment 3, so we know experiment 3 is going to be our first step, find that, at an engine speed of 2,200 RPM, so that'll be number 2, find that. At this engine speed, which of the following sets of octane numbers would most likely have been determined? So we need octane numbers, would most likely have been determined for fuel A and fuel B. So we need octane numbers for fuel A, that's number 3, and fuel B. And we see that here, we've got fuel A and fuel B, and then it's got numbers here and here. So let's start our step by step. We go to experiment 3, and we find it right there. Step 2, find 2,200 RPM. So we see RPMs here, so that's engine speed. And if we look at the ranges here, it goes from 1,500, 2,000, 2,500, 3,000, 3,500. So 2,200 is not in this, but this is called an interpolating question, and I don't know if that's the right way. So I don't know if it's interpolating or interpolating. I don't think it really matters. It just means in between. So we have in between. So 2,200 would be kind of in here, right? And they do this a lot, the ACT. They ask you to come up with a value that's between two that are on the table or in the table. So if it's in between these two, and it's kind of halfway, right? Because halfway between 2,000 and 2,500 would be 2,250, right? And we have 2,200. So it's as close to halfway as I think we can, because it's not asking us for exact values. It's saying, it's using the favorite ACT phrase, most likely. So we just have to get close enough. So what we'll do is we'll take the values, the in between, the middle number between the two that we look at. So we need the octane numbers. So octane number is right there for fuel A and fuel B. And again, we're looking for it at 2,200, which is between this number and this number and this number and this number. So basically we have to find the average. And to find the average, we would add both of them and divide by 2, or we can just do it by taking the first number, 96.6, this one here, and this is 95. If we subtract them, we get the difference between them, and we just divide that by 2, and that will give us the kind of middle number, and that's 0.8. So that's kind of where 2,200 is going to be, is that you would add like 0.8 to 95.0 and you get about 95.8, or by the same token you could subtract it from 96.6 and you would still get 95.8. So we'll look over at our answers and see, does anything come close to 95.8? F has 95, that's not bad. This is 96.1, so that's the closest. This is 96.6, 97.6. So this is out, H is out, because it says this says it stays the same as this number here, and it doesn't, because that's the value of it at 2,000. And this is, we need 2,200, so H is out, and this says it's 97.6, so it's out. So we know we're just dealing with F and G. And at this point in the exam, if I was doing the exam, I would just mark it as G and move on. But just to, as this is an instruction video, we'll do the second one so you can see kind of what I'm doing. So again, we're looking for a value. We've got the value here for the thing at 2,000, and this is for 2,500, and we need it at 2,200. So we need a value that's between these two. So if we do 96.1, minus 95.4, we get 0.7. So we need halfway between that. So that would be 0.35 or so, and we need a little less than that. So let's say it's 0.3. So we can do 96.1 minus 0.3, or take the lower value 95.4 plus 0.3. And both of them are going to give us about 95. This is going to give us 95.8, 95.7. So it's about 95.8. And if we go over to our answers, we see that, in fact, G has 95.8. And this one was close enough at 96.1. So we're just proving the point that it is actually G.